Did you know Earth has an electric heartbeat? And for decades, scientists might have had it all wrong. It turns out, this vital pulse flows in the opposite direction from what we thought. So, what is this heartbeat? Our planet is wrapped in a giant magnetic bubble called the magnetosphere. It's our planetary shield, protecting us from the solar wind, a constant stream of charged particles blasting from the sun. When this solar wind hits our shield, it creates electric currents and magnetic forces. This interaction is the engine behind space weather, from those stunning auroras UV seen to powerful storms that can knock out satellites and even power grids on the ground. For a long time, the model was simple. Scientists believed the morning, or dawn side of Earth was positively charged, and the evening, or dusk side, was negative. Think of it like a battery, with energy flowing from positive to negative. It made perfect sense. But new data from satellites and advanced computer simulations are painting a much more complex and frankly upside-down picture. A team of researchers led by Professor Yusuke Ebihara at Kyoto University made a groundbreaking discovery. They found that the morning side of the magnetosphere is actually negatively charged, while the evening side is positive. This complete reversal is a huge deal. Their findings, published in the Journal of Geophysical Research, are refining our entire understanding of how energy flows through Earth's space environment. This could dramatically improve our ability to forecast space weather and protect our technology, both in orbit and right here on Earth. So how did they figure this out? The team analyzed data from NASA's Magnetospheric Multiscale Mission, (OMS). These satellites are designed to study how the Sun's and Earth's magnetic fields connect and disconnect, a process called magnetic reconnection. This is the very mechanism that explosively releases solar energy into our space, lighting up the sky with auroras. Alongside the real-world data, they ran super-detailed computer simulations. The results were clear. While the areas over the poles behaved as expected, the regions near the equator were completely flipped. The charge patterns were the total opposite of the long-standing theory. Professor Ebihara himself asked the key question: why do we see opposite polarities between these regions? The answer, it seems, isn't about static electric buildup, but about movement. When solar energy hits our magnetic field, it gets the plasma, a superheated gas of charged particles swirling around the planet. Here's where it gets interesting. On the dusk side of Earth, this plasma flows clockwise and moves toward the poles. At the same time, Earth's magnetic field lines point from the southern hemisphere to the northern hemisphere. Near the equator, these lines point up, and near the poles, they point down. So, you have the plasma motion and the magnetic field lines going in opposite directions. This interaction completely changes how electric charge builds up, creating the reversal that the scientists observed. In other words, the electric force and charge aren't the cause of what's happening, but the result of the plasma's motion. It's like discovering the river is carving the canyon, not the other way around. This new understanding adds a crucial layer of detail to our models of how solar energy gets into our upper atmosphere. And it doesn't just stop with Earth. These findings could help us understand the magnetic environments of other planets like Jupiter and Saturn. Their massive magnetospheres interact with the solar wind in similar ways, so this discovery could unlock secrets across our solar system. It's a reminder that even our own planet still has profound mysteries waiting to be uncovered. Thanks for watching. If you found this fascinating, make sure to like, subscribe, and hit that notification bell for more deep dives into the wonders of our universe.